circuit screaming sparks ignite. Shadows moving, neon light. Keys are clacking fast and tight.
Hello guys, welcome on DevOps channel. Today we are going to build AWS infrastructure using Terraform. It will be a simple one. We will cover VPC building and some good practice regarding catalog structure and global settings, but I will try to keep that simple in this episode. Let us start with creating structure for our Terraform, for our catalogs and files, and we could do that manually. So we could start from creating we could create first let's say the global catalog, where I would like to keep some global settings for S3 backend, and let's call it like that. I will create also the main.tf, the provider, sorry about that. Provider.tf, and of course we can add variables .tf. Okay, so we will use it to create a global part of infrastructure for keeping the F state in the cloud, we will also need a catalog for modules for our environments, and basically this is because this is quite a lot of catalogs and files to do and copy. Because I'm planning to reuse that also, and it will be used for other projects. I think I can create something like a bootstrap sh file for myself, and let's just make that a bash script, what I want that script to do is to create a catalog structure and file structure actually. We need to declare first directory. Okay, so I need the terminal also, and basically I want to open a Ubuntu WSL on my Windows. I will need it later. We are using declare with large A parameter, which stands for associative arrays. So we want to use named keys to create those. I named that dir, so I want to have keys like modules, and that's gonna be a VPC module, I will also, well, basically we will use the same files. So I will follow that way because the script will be simple to write. .tf and I didn't make a typo, okay, outputs .tf. So in most of our modules we will have that three files. I will just leave them like that. Later on we might add or delete any of them if we don't want to, or they won't be required. But for now I want to create those. Oh, I didn't copy them. Close. Fine. I only have 4, so I want to have definitely the VPC. I want to have S3, for example, and that for the infrastructure. I created manually the global catalog, so I won't be adding that. Well, if we were going to build a larger infrastructure, actually I might create that catalog infrastructure. It doesn't, because I want to use that as a base for later projects, then I just may add for now empty catalogs and create those files right now. Even if I am not going to use it, it's only for my labs and for later usage. So we are fine with that. If not, we actually wouldn't add such catalogs as, I don't know, as knuckle or SG groups, for example, which I will place in separate module. Okay, so we've got most important one, that's VPC, S3 and EC2. I'm not sure if we will create RDS yet. Okay, so let's leave it that way. And of course, we want to create catalogs for our environment. So I want to have something like environment typo. Sorry by that. So we'll need the dev catalog, and of course we will have the main df variable and outputs in that catalog. And also what we need is to have test and prod environments. So with that we have scripted our basic catalog structure. I would like to create it using a loop. If you already have like your own catalog structure for your projects which you like to use and you think it's the best for you, it's good to write a script for it. So that you can reuse it, and it's better than create it just by running each command in the terminal. Okay, so we want a loop that will go through our table and will create the directories, directory structure according to what we have in a catalog value. Okay, so this is it. Now we want to create a files. So let's name our variable files. Let's assign to it each time we go in the loop a different value, just in case. Well, they actually will be the same, but if we had something different or change it, it would create different files. Okay, so we want to have that files and we want to run through that. So we want to go for that for each file in files. We're gonna create a file. And actually that's it. I'm gonna just echo that the whole thing was created. I'm not gonna echo each time we create any catalog. Okay, so let me just look if I didn't make any typos or anything like that. Seems it looks fine. So let's save that file. I would like to move it from this location, like to the top, and let me see it. Okay, so I've got that bootstrap sh file, and let's make a test if it works. Okay, so it says the project structure was created, and let us see if the files were created. Great, so we got the project structure, which I wanted. So we got environment and dev, prod and test one, and if each we've got the main file, and outputs and variables. Also, we got our modules, which will be reused by our environments. Okay, so this is an example of keeping all environments in one repository and resources organized in modules, which we can reuse. And with that, we actually may move to start creating our files. First we should start from creating a space to hold our tf state file for our Terraform. To do so, we need to create a bucket. Yeah, actually I could use this one. I already had it open. It seems on one of my browsers. I wanted to go just to docs Terraform. And with that, sorry, I'm trying to move my window. I wonder if this is fine with you to see it that way. If you see properly everything on the screen, I hope so. Okay, so we're gonna go to AWS provider and what we want to do is to find how to create a space for keeping our tf state. Okay, so with what I said, we need to first create a provider, and provider in our case it's gonna be of course AWS, but the region we're going to take is US East 1, And basically, because this is the place where where I can run that whole app for free for testing, because I'm using Cloud Guru and I do have access to some sandboxes over there. Let's save that file. We are going to use that just in case if I really do not actually remember all the commands. I'm using a tool which currently allows me to update, which actually gives recommendations for the name, so it's easier for me to write it, but just in case we will use the documentation. And if you creating that for the first time, I recommend to going through that both through guides and also through functions, which you can find in that documentation. And there is always at the end description of the parameters, which are which of them has to be used and which of them are optional. Yeah, that's it. Basically, if you are creating such infrastructure for the first time, I also recommend to just going through AWS and go through creation those resources using the user panel. Because basically you will see all the parameters, and those parameters can be set using later on using the using Terraform script. But if you do it through the user panel, it will be easier for you later to work with Terraforms. So even sometimes if I did not create an infrastructure and I need to create something new, it's always good to start with creating that through the panel. If you get some experience, then later on you might want to just create everything in scripts. Okay. What I want to do is well, I'm gonna name the bucket later using the variable, so it's gonna be bucket name, and we'll use that variable later on. I did not update this one. Okay, so let's call that on state. This is the name. This will be the name of the resource. And what I want to add and what I want to set for the bucket for the state bucket is a lifecycle. And for that one, you should always prevent that from being destroyed. So secure that so that you would not lose your dev state file for your infrastructure, because you won't be able to recreate it that simply. At least you will have issues with that. Okay, so next we're gonna create a bucket versioning, which is also good for that one where you want to keep your state file. Link. Okay. I guess it's okay. And let's name that. How should I name it? Maybe like just that. Okay. Let's just write. We will need to use, well, basically to set that I need to set a bucket and a versioning configuration. But let's say that you don't know it. So let's go to let's go and find that in the documentation. Did it? Oh, okay, so it didn't find it. Fine, resource bucket versioning. Okay, great. Now, okay, so as you can see, for the bucket versioning, we need to set up the bucket. So we need to use the, in our case, this will be our AWS S3 bucket dot terraform state.id. Here we go. So that's our bucket that we have earlier created, and now we want to add the versioning configuration, which needs to be enabled. So let's do that, and status. And let's set that for enabled. That's fine. Now, for this bucket, we also should set the encryption. And let me just search for that. Okay. If we are going to create, let's start with this. Let's start with here, and let's do the AWS S3 bucket, and I want to find server-side encryption configuration. Let's just name it. It's gonna be the F bucket and encryption. Let's do it let's name it like that. And let's pick the bucket as it was terraformed. Well, you see that it already proposed me my bucket. Okay, so we have the bucket, and to that we also need to create a rule, but I'm gonna just go to the documentation, and let's see the server-side encryption. Okay, so we've got a rule. I actually can copy that. Let's do this. Okay. Let's do it like that. Except that I'm only interested this time in SSA algorithm. Let's just correct a couple things. Nice looking spaces. And let's go down to see. Oh, I thought that there will be a table at the end where you can find the values. Okay, so there is no table, but there is a description. Okay, fine. So we've got the SSA algorithm, and we are going to use the ISA 256 in that. So let's just change that to our SSA algorithm. And let's move to creating a log, because we not only need a TF state file, a place to keep that, and of course protect that from being destroyed and encryption, but we also need to create a TF log for that TF state file, so that we could actually safely work in a group, because when somebody is going to run and will be updating our infrastructure, then this file will be changed to log, so that in the same time there won't be some conflict with another person trying to overwriting our configuration and messing up our infrastructure actually. Okay, so that's another important thing that we need to create, and that is you can go actually to HashiCorp website just to read the documentation, because it's there is how to create how to create that TF state file and properly to create log. HashiCorp Terraform, and probably I will get something like state logging, and the backend is free. So I recommend going through the documentation. As you can see, I already read that earlier. You will find here of course useful information how to take care of protecting that state file, how to create it, and of course how to log that. Also there are some good practices here. So of course, even if you were trying to run and do something and use AI just to make things easier for you, I still recommend going through the documentation. Okay, so let us create the DynamoDB table, because this is the current method how you should actually keep the TF state file log. So it's recommended by AWS to use the DynamoDB table. And what we need, I wonder if this will find us something about locking the state. Well, it didn't. Okay, so never mind. We just want to of course have a name of that resource, so we're gonna add a name, and we're gonna name that using the variable later which we add. So I'm just going to name that Dynamo DB table and the TF bucket log. It looks nice. Okay, so we have couple parameters that we can set here. Is this all of them actually? Okay. Fine. Let me just view that. We've got range table name. I actually think there should be more of that. Sorry, it's showing me AWS DynamoDB table item. I'm sorry by that. I just didn't look properly. I don't want the item, I want the whole DynamoDB table and a module, so I could go through those attributes in that table. Sorry about that. I was just talking and describing what I'm doing, and I didn't look carefully what I'm actually showing you on the screen. So yeah, so what I want to set is a billing mode actually. I'm interested in that, and because I'm not going to use that very often, so for me the best model for that is actually to use it by pay per request. I'm gonna copy that and paste it. Okay, so we got the billing mode. Great. Now let's add also a hash key. So the hash key, let's name that just a log ID, and let that attribute, and that attribute is gonna be name log ID and a type of S. Okay, so what I would also like to add, I did not create the output file in the localization, so this, well, it's kind of special localization, so I'm just going to break the rules, and I will add the output bucket name and a value in here with AWS S3. Bucket Terraform state and bucket. Okay. And let's add the description, and the description will be that this is an S3 bucket to store the Terraform state. Okay. So guys, we are almost done. I'm gonna save that file, and we still need to add our variables, which I was going to add. So we wanted to create one variable was tf bucket name. So I'm just going to copy that, and I'm going to write variable. Great, and here we add the tf bucket name, and this will be a type string, and the description, let's description, it will be name of the bucket, name of the, actually let's write the tf state bucket. Okay, another variable which we were adding was the AWS DynamoDB tf bucket log. So this is one more which you want to create. Name, and actually I'm going to copy that. but I'm going to add a default value here, and I'm going to name it df bucket table. df bucket table. Okay, cool. So right now we have our global S3 backend settings ready to be run, but we are not going to run it yet. I just want to do it at the end and run everything so that you could see the proper way of running those Terraform scripts for such infrastructure. Okay, so we've got the S3 backend, and now I would like to start creating our VPC. So this is actually gonna be quite a lot of resources. Let's start with main file. Basically, I want to create like a VPC which has a public and a private subnets, and I would like also it to use route tables and NAT gateway, and also the internet gateway. So we've got a couple of resources that we need to create. The first one is, of course, the AWS VPC. That we can name VPC. Okay, let's add the CDR block, which is a necessary parameter for the VPC, but we are going to pass that as a variable. And we're gonna do the variable VPC CIDR. For the VPC, AWS VPC. Let's see that. For the VPC, for this VPC, I would like to, let's go to parameters. I would like to enable the DNS support. So let's go with DNS support, and set that for true, and also let's enable, as you saw the name a second ago, DNS host names. So okay, so we've got those two. We can add also tags for our VPC. It will be easier for us to, well, tags are always useful, but I also want to create those tags using parameters. So what we are going to do, we are going to use a merge for our tags, and we're gonna also use name, and I want that VPC to be named by variable, which I'm going to use later on, the variable name. And a VPC. Okay. And what do I have here? What I did wrong? Sorry. I guess it should not be. That type of bracket. Do I miss some bracket here, or I'm sorry, I look at that and yeah, I don't saw that. First, I didn't use the variable. I didn't use. I did not also close properly everything. One more time. Yeah, I lack one or more of those here. Yeah, okay. So now it's fine. The next thing that we want to create is gonna be an internet gateway, and we gonna use the AWS internet gateway resource for that, and we're gonna name it classic way just EJV, and we need the VPC ID for this resource, and it's gonna be vpc.id, because this is how we named that. Yeah, and we want to add a tags, of course, and the tag I want it to be named by the name, but with EGV. Okay, so we got another resource. The next would be creating a subnet. So we're gonna use a resource, AWS subnet, and we are going to create first a public subnet. And let's go with that. So that's right. Count. We are going to take measured length of variable call of public CI. Public, we're gonna create later on CRDR because I want to dynamically calculate the CRDR. I want to count those subnets based on CRDR. So okay, so I need to add the VPC ID, and it's gonna be, well, our VPC ID, but also the CRDR block is a necessary parameter, and we are going to create that link public subnet CRDRs and count the index. And we also are going to need to add one more parameter, public IP launch, true. We'll set that for true, and we will also add the availability zone. Availability zone has parameter sorry about that. I guess that what we want to use in this case is I want to use element and use variable AZS. I will name that value like this, and we will later add that to the variables. Okay, and of course we need to add a tag. And let's copy paste something we already had written earlier, but this time the name we're gonna create it in a dynamic way. So we're gonna use like public and we are going to use our count index. Plus one. Okay, so yeah, so this way we will create a dynamic tag for our subnet. Fine. We have added a public subnet, but we also need a private one, and we're gonna copy that, except that we will use tag private. Let's start from that. And we will set the parameter map public IP on launch to false. And I think it looks okay right now, actually. Yeah, so okay. So I think we have I think it's okay. One of the resources that we want to use also, at least I plan to use, it's NAT gateway, and a NAT gateway resource needs to have the AWS AIP also. So we will have to create first AIP for that NAT gateway. So let's go to AWS AIP. And here we have some nice example, so that we are going to use a resource AWS AIP. We're gonna name that just NAT, because it's gonna be for the NAT, and what we want to is the domain, and that will be VPC, can be VPC, and I want to add another account that will use the variable create NAT, and let's make it true or false. And of course the tags. So the tags goes down here. And the tags will be, in this case, we don't need to calculate it. It will be not AIP actually. Yeah, okay, so this looks fine. We've got another resource, and we can move to creating our AWS NAT gateway. So I'm gonna use one more time the resource. I'm going, did I get some? Oh, okay, I was hoping to that there will be some better proposition of resource. Okay, of definition of resource. Fine. So I want to create like AWS NAT gateway, and I'm going to call that NAT, just like that. We are going actually to add count for var create.NAT, and we will make it true or false. Okay. Now, for the NAT gateway, we need the allocation ID. So let's add that. Oh, what happened here? Oh, okay, it's okay. We need allocation, and that allocation is our AIP, but it's gonna be .NAT. And 0 to pick up the element, and ID. Okay, and we have type over. Okay, so now it looks better. What we want to create next is to add a subnet ID. Subnet ID, and that's gonna be our public ID table. Okay. So that's subnet ID. That resource will depend on one that we created earlier, and I mean the internet gateway. So we need to add that depends on parameter. Okay, so we've got this, and I'm gonna just copy that tag, and it's gonna be NAT. Okay, great. Guys, I'm going to take a break, and I will be back after the break. See you for a couple minutes. Okay, guys, so we're back to recording, and I want to show you something. First, I want to show you a basic setup for AWS network. So usually when you build infrastructure, you create something like a public subnet for your front-end application, a private subnet for backend layer application, and let's say another another private subnet for databases. When you do that, you need to also allow traffic from private subnet from your EC2 instances, for example, so that they could be updated. And of course, you still need to block the inbound traffic coming from the internet. So that's why exactly we needed to create a NAT gateway, so the traffic could go through the router and NAT gateway and then through the internet gateway. But the NAT gateway allows only internet outbound traffic to pass to your private subnet. And internet gateway allows internet inbound and outbound traffic to go to your public subnet. So with this additional explanation, we can move forward, I think, because we're building something similar. Although there won't be that many availability zones at the end, I'm just planning to do this type of setup. So that's exactly why I created the NAT gateway and Elastic, and of course another resource for the NAT gateway, the Elastic IP. Okay, I did create the public subnet. I also copy pasted to have another to have a private subnet, but I didn't finish that. So let me just correct couple things. I think that okay, so let's go with private. And let me see if there is something else I need to change. I think we're okay with that. So we can move to creating our route table. And to that we of course need AWS route table. Yeah, okay, because we also will need our AWS route, and it's gonna be okay, and we also need to name that, so this will be our public default, and we still need to create AWS route table association. And let's name that a public, just a public one. Okay. Okay, so we need those three resources. And the same thing will go for the private route table, except that we're gonna name it private. And it's gonna be it. Okay. So let us add the parameters just to double check with what we have in the documentation. For the AWS route table, we need VPC ID, of course, and we had our VPC name this way. Okay. We will also need to add a tag. I'm gonna copy that, but we'll add here a public LT. Let's name it that way. So this will be our public route table. Now let's go to AWS route. In a route, we need to pass the route table. Let me just see. Well, we got AWS route table association, so this we will also need that. Let us just find the proper AWS route. It's not impossible. Basically, this resource should be here. Resources. Let me go copy that one more time. And AWS route. It does find it, but you need to still put some effort to get to that. Okay, so we've got our AWS route, and we're gonna add, as I said, our route table. We use the route table ID, AWS route, and it's gonna be our public route table. Oops. And we still need to pass the destination CNDR block, and this, in this case, it's gonna be 0.0.0.0/0. It's just now another one is of course the gateway, and we are going to pass our gateway, internet gateway GV and its ID. Okay, so with this we have our AWS, our first AWS route, and we need to create an association. So what I want to do is take in account the number of our subnets. Basically, to do that, first we need to pass two things: the subnet ID and the route table ID. And if you're only adding one, then we could just copy paste that. But what we want to do is that we want to first count the length of our AWS subnet. So, and we want to use it to index our public subnet from our table. So let's go with that, and it's gonna be subnet ID, AWS subnet, public, but we use our count index to get one of our subnets. If there will be one, then this will still works. If there will be many, this will create a route table for each count. Okay, let's go with gateway ID and add AWS Internet Gateway GV ID. Great. Okay, so what did I do? Sorry guys. Sorry guys. I was supposed to add route table ID. Great, so we've got our AWS route table association, and we also need to add the same for our private route table. So let's go with that. Let's just copy paste that, but we will name that private write table, and we are going to also create our AWS route with private ID, but I will add here another parameter for creating a net. So with this we will be able to pass the true or not for creating the NAT. A gateway for that for the private route, and as we are creating this route, we are going to change that for NAT gateway ID, and this is going to be our AWS NAT gateway, and it's gonna be one or more. We call it 0. Well, I mean, if this was going to be more NAT gateways, then we could create one per. We should create one NAT gateway per our private subnet. Next, we need to add our association, so we are just going to copy that, of course, and we are going to change that for the private. That's gonna be private table. And of course here. With that, I guess we have everything in our VPC main file. Okay guys, so we are done with our main VPC file for our VPC module. We still need to add variables and the outputs. So let me just start with the variables, just to make things easier. Let's split the screens and let me open here my main file, just to make things easier. So so one of the variables that we said was the name, and the name will be type of string. And of course we should add the description actually for each variable, but as that would actually take additional time, I'm not gonna do it at this video, but you should do it if you're going to prepare that, if you're building infrastructure not only for a home lab, but if you are doing some project, you should definitely add that. Okay, so we're gonna add our variables. We still need like public subnet CRT. We just need a private CRD, and we need oh yeah, the availability zones. We did add that parameter to create a NAT, yes or not, and we also use the var tags. So let's go with this one first. This one will be type map, and this will be string. And the default, I'm gonna make it empty actually. Okay, so the create NAT value is type of bool, and the default value is true because we have to create it. Availability zone will be type. This will be a list, and it will be a list of strings. Actually, I'm going to copy that here already. So both public and private subnets will be type list of string. So I'm going just to copy that. And we're good with those variables. Okay, so these are variables. We also need to output some of them, and we need to output the VPC ID. And the value will be our VPC.id. Next will be output of our public subnets. And this is gonna be a value from a table. And also the private subnets. Okay, so with that, I think we have all the necessary basic things for our module. We've got the VPC. Now, what we can prepare? Well, with this actually, we could move to creating our first dev environment infrastructure, of course, without EC2 and settings for security, RBS 3 and knuckle. But with this, we can move to creating our dev environment. So in our dev environment, we actually I can close those one. In our dev environment, we need to create our VPC module. And of course, we need to pass the source for our module. And according to our directories, this will be, we move 1, 2, and go to modules, in this case, modules VPC. So that will be the path for, this will be the source for our VPC module. We're gonna name that dev, as this is our dev VPC. We need to pass for the VPC CRDR. This is exactly why you can go to a user panel, try to build that first without using Terraform. So thanks to that, you will know some typical addressations and what actually AWS even by default pass you through the panel, and you can see also what exactly works there, so you know the values that you can pass here, and you don't need to test with running that multiple times. And of course, it's great to first have an architecture of the network which you want to do. As I already did it a couple times, I'm just moving forward with that and not going too much into details. But of course, if I was doing a project, I would prepare first the architecture, draw everything, for example, in Draw.io, which is a very nice tool for making projects of infrastructure, and I use it quite often. Not only for that, of course, but that helps. So we're gonna create two public subnets, and just to show, and I'm going only to create one private actually subnet this time. I just want to quickly test and show that what we already did works, because later on we can build other resources around that and create a full working infrastructure. So for the availability zones, I want to have that in two availability zones. So I want to have it like US East 1A and US East 1B. We earlier create the parameter for the create NAT. The default value is true, but I'm going to set that anyway. Well, I'm just repeating that because it's easier for anybody who is going to view that dev environment to see that this value is set for true, and if he doesn't need to go to the resources to variables to check what is the default value. You will see it here. So sometimes it's good to repeat that. Okay. And the project. I just wanted to tag the project to make it looks nice. This will be our example network, so which let's just call it like that. Fine. So we've got our main file ready. What I did not do is I did not add the provider for our Terraform. So basically I should create a file provider.tf. And I guess I need one more in here. Provider.tf. So let's just add that. And as for my dev environment, let's go and also create that one. So I want that it to be provider AWS with region US East 1. And we will add a required providers AWS source, it will be HashiCorp AWS, and I'm gonna use a version above 6. Okay, so we've got our provider setup. We already created our main file, and what I did not create, well, actually I could add here, for example, a variable, which would be nice, like string to, like a variable, the default name of the of our infrastructure. Great. So we've got also the name. Now, now we can actually try out to build it, and I'm going to try to build it using my card in Cloud Guru, which allows me to use the environments there for training, so let's slowly start with that. Okay, guys, so what we're going to run is we are going to run a Cloud Sandbox using well, plural site. Earlier it was a Cloud Guru. So I'm gonna start that. It's gonna pass me the credentials. So it gives you the access key and the secret access key. And because this is a one-time login, I'm not worried that you will see that it will be removed later on. So for this lab, we will need to create to pass our Terraform credentials in our Terraform CLI to start building that. So let's do it. Okay, guys. So let us just go to our setting file. Let's go just nano AWS, and this will be credentials. And we're gonna to change those keys, which I have here. And I'm gonna copy paste that one and the other one. And we are going to save that. And with that, we are almost ready to go. I'm just logging in the browser for that account, so that I also could show you that there is nothing there in AWS. So we've got no S3 bucket, no infrastructure inside of the VPC. Yeah, so well, there is one default, but that has a different CIDR. We're gonna check it out how our resource is going to be created. We're gonna observe that. But now, where we are, we already created our modules. We created our setting for the one of our environments, and we got provider. We also added the credentials to our Terraform. So right now, I would like to first, maybe we can run just fnt check and validate, just to make sure that things are... Oh, okay, so there is a missing provider. Let me check that out. Okay, that's only means that our Terraform is not initialized. So let us go first. This is the proper way of initializing that infrastructure when you create the environment and the modules separately in the global. So let me go to global S3 backend. We're gonna check our files here, and we're gonna run Terraform init. And we already got some errors here. Okay, so that variable cannot be used here. So let us go to that variables in the bucket, and let's see that. Well, you can see that I did not make that string, pass that string properly. So we're gonna fix that, and let's see if it's going to work. Well, nice. So Terraform is initializing. And it's done. So now we can run Terraform plan to see what it will create. And it's going to ask us for our TF state bucket name. So I'm going to name that bucket, for example, TF state $190. Oh, sorry about that. I just gave it a random name this time, but if you know that you should actually think about the name before running that, as this is gonna be your bucket name for the project, so it definitely should have something, have some name suggesting, for example, the project, the bucket is, and the purpose for what the bucket is being used. Okay, so it showed us a bunch of things it's going to create, and where it's going to create. It's going to create the bucket. So I think we can run the command and try to create the bucket. Let's run the Terraform apply. Yeah, so let's name that, as I already said, TF bucket 190. Maybe TF state bucket 190. And we're gonna confirm that we want to create all the resources. You can review that it also is gonna create a DynamoDB table. We can go to our browser just to see that our TF bucket has its creation date, so it was created, and also the DynamoDB table. I'm pretty sure it's great. Tables. Let's go to tables and see that we get our AWS TF bucket table with log ID and partition key. Great. So we've created the first element for our Terraform infrastructure. So we've got the TF state, which will keep our current infrastructure configuration, and it's been kept safely in AWS. And also any other our team member also can try to build and nothing will break, because we got the log ID on added by our DynamoDB table. So now we can try to create our environment, our dev environment. So we can go to that was in global. So we can go now to environments. We can go to dev environment, and actually here we could run the Terraform init. Let's do that. Okay, let's check that out. Let's just go to our provider. Let's check that out. Maybe it has source version configuration aliases. Let's move that here. I don't know, I'm not 100% sure why it complains about what we have here, because you get Terraform and providers, and it looks okay for me. If not, I will have to. Okay, so there is definitely something with that version. Sorry, I'm blind. I'm blind. I was thinking, what the hell is going on? Okay, I thought that this was because of there was no space between those, but that's not the case. Okay, so let's run it. That was a typo. Sorry for that, guys. It's always to watch when somebody is creating files and doing some infrastructure setup from behind, because you see more than the person who is actually doing and talking about it. It's almost always like that. Okay, so we just initialized the Terraform here. Let's run the Terraform validate and see if everything is okay. I hope so. Yeah, so okay, the configuration seems to be fine. Let's run the Terraform. Wait a second. I should check one more thing. Yeah, I just forgot about one thing. This is exactly what I mean. Basically, we did create the main file, but we didn't create the Terraform backend, so it doesn't know currently where the Terraform where is the Terraform bucket to keep the Terraform state. So if we run it, yeah, it will not know where to keep that. So we want to keep that in our cloud. So I'm going to actually create another file here, and I'm going to call that backend.tf. And in that file, I'm going to add a Terraform block. I'm going to get a backend as free. And I'm going to pass our bucket here. And our bucket was named. Let's just go to our page, and even though I remembered that correctly, but it's always good to to pass that proper name and make sure it works with the first time when you try to run it. Okay, so we're gonna give it a key, a Terraform TF state, for example. We're gonna pass the region, and it's gonna be US East 1. Even though the buckets are global, sometimes it causes error. This is why I'm actually passing this US East 1 region. TF bucket. And it's gonna be encrypted, and it's encrypted, so it's gonna be true. TF bucket table. I think it was. Let's just make sure that the DynamoDB name is correct. Let's go to tables. AWS TF bucket table. AWS TF bucket table. Okay, so that's also correct. I'm gonna save that, and now we run one more time the Terraform validate. Sorry guys if you hear something in the background. It's just a toy of my cat which turned on. Okay, so we can try to apply those changes. Let's run that. Oh. So we need to initialize the backend. Let's run Terraform init one more time. Great, so the bucket was configured. So now we can go with Terraform apply. Let's do that. Well, so okay. Yeah, we want to perform those actions. Of course, you should review first everything here, but I'm pretty sure it should be okay. And we can see that it starts to create our resources. We can actually go to the VPC here just to observe that it did add our dev VPC, and it's gonna add also the subnets and the route tables, but let's wait for that. Yeah, so we can see that it's still creating the subnet. Okay, so we can see that it already create our VPC, our two subnets, two public subnets or route table. Our NAT. It's still creating the NAT gateway. But as you can see, this Terraform script works. The important thing is that as for this global catalog and Terraform, you only run the init function, and Terraform apply you run only once, and then you operate on your environment. So you can change something here, and then you just run that from run init and apply from the catalog of your environment. Of course, remember about the proper settings of your credentials for the account. Oh, okay. So we've got one conflict there. It's my fault. Invalid conflict, the CIDR conflicts with another subnet. Yeah, okay, so let's just check that out. It complains about the VPC in the modules and here at 28. This conflicts with another subnet. It's a bit weird that it conflicts with another subnet. I wonder what is the cause. Because when you go to our to settings of our networks, everything looks fine. Actually, let's just try to create two of those subnets, of those private one. Basically, the values were properly passed. So let's try one more time to run Terraform after saving that file. The nodules DPC. Okay, now I got some. I guess now I got some error here. It's actually that. Okay, wait a second, because it's something weird is going on here. Okay, so that's fine, but we'll see if it complains about the CMDR. Yep, it still shows that it conflicts with something. That's a bit weird, as it created two public subnets. But it does have issue with the private one. Okay guys, so we're back. I just paused the video to not make it too long, to check what was wrong. The thing is that I actually made another stupid mistake and typo, because I did not replace public with a private one. So that was the cause of that we had a conflict with our subnets. And after running that in that configuration with changing the properly name, everything worked fine. So it's our resources were created. I'm gonna just show you that if I run apply now, it should be fine. But with that, basically, we got everything what we needed was created for our basic infrastructure. And we can just go and add next resources to that. So EC2 instances, security groups, network access control lists to control traffic. Of course, we've got only 2 availability zones, but you can add another one. If you want to create, for example, RTS database, the minimum AZ is 2, so this should work well. As you can see, there is no changes needed to be added, so everything works fine. We've got 4 subnets as we as we written in our main file for our dev environment. So great, everything works, and I think we can end this this episode. And maybe we'll reuse that later on when creating a more complex setup for the environment. So have fun in trying out that by yourself. I also recommend you to using those platforms like Pluralsight, Cloud Guru, which allows you to run your own environments for the price of for the quite cheap monthly price. You can test many things, and you have access to really good courses there to learn by yourself and prepare for the exams. So good luck, guys. Have fun.